8.2, impact of organized data. When we pay some cost to organize our data, there is a cost you need to pay. Yeah. You need to look at the benefit. Is the benefit big enough to cover your costs? Okay, yeah, to make your investment worth of it. Okay, all right, so let's look at our question number 6. Element uniqueness problem. Element uniqueness problem. So from the name, you can guess the meaning. So given an array, yeah, how to check if all the elements are distinct. That's simple. But you want to find the fastest algorithm to check it. You can do it. Everyone can do it. But think about, is your algorithm the best? Can you do faster? Right? Yeah. Yeah. So let's use 2 different methods. Then we compare. Okay. All right. The first one, brute force method. Brute force. Yeah. So here, the brute force, so we mean you do not apply any technique. Yeah. So you just work on it directly without any special technique. Okay, brute force. Yeah. All right, yeah. So do nothing to organize data. We don't do anything. We just do comparisons directly and check if we can find there are 2 elements in the array, they have the same value or not. We do all the possible comparisons. You may need to do all the possible comparisons. Yeah. All right. Here, the data organization part is no cost. So you work on it directly. So you do not do anything to organize your data. Yeah, so no cost in the first step. Okay, yeah. All right, so now let's look at the comparisons. All right. First, in the first round, we want to see if the first element appears anywhere in the remaining elements, happen to have the same value in the with any of the remaining elements. Okay, yeah. You need to do n-1 comparisons, right? The first one, you need to compare it with all the remaining n-1 elements. So n-1 comparisons for the worst case, right? For the best case, you only compare with the first one. They happen to be the same. Then you have the answer. Yeah. Because uniqueness, no, the answer is no. The first element equals the second element. The answer is no. Not unique. Not unique. Okay? Yeah. For the worst case, you need to do n-1 comparisons. Okay? Still not enough. The next round, the second element, you need to do comparison with all the remaining elements with n-2 comparisons. The worst case, still, you cannot find a match, still different values. So then you consider the next one by one, until the second to last one, you do one comparison. Still, yes or no, it doesn't matter, but you have done all the possible comparisons. That's the total number of comparisons. But for the worst case, okay, yeah. Yeah, the last one, Yeah, so you do not need to do comparisons. So we can calculate, we can do the analysis of efficiency. We just count the number of comparisons. Best case, this situation, all right? Yeah, one comparison, the best case, okay? Worst case efficiency, yeah. So that's an example, okay? One of the examples, you have many different examples. One of the examples, that's the total number of comparisons, okay? Best case, worst case. Yeah. Here, the question, how to calculate the average case? Think about it. How to calculate the average case? Okay, yeah, not that easy, right? Your average case, because you need to consider all the possible cases. Then you do the average. Can you exhaust all the possible cases? Right? Yeah. Think about that. Probability. Yeah. So what kind of probability assumption you can make? Yeah. Right. Yeah. Oh yeah, the probability. Yeah. So you can think it this way. Yeah. Because two possibilities you consider, unique elements and non-unique elements. Between these two groups, there is a possible probability, right? So uniqueness, what's the probability? Unique. Non-unique, what's the probability? Yeah, you need that probability. Good. Yeah. Here, I do not give you that question. You just think about it. Okay. All right. Yeah. So the average case, a little harder. Yeah. Just think about it. Yeah. Yeah. You can try. Yeah. All right. Next, we want to, that's our method number one, right? Now we do a different method. Method number two. Yeah. Pay for some cost to organize data. So let's do some data organization at the beginning. We try to make our data well organized. Then we may take advantage of organize the data. Okay, now let's do our method two in this way. Okay, investment in data structure. Here, we do some investment here. So we sort the array first with certain cost. We sort it. Now, before we check uniqueness, let's sort a whole array. We know it's costly. It has some relatively big cost. And we want to see if it's worth it or not. Worth the sorting extra work. Okay, yeah. But here we do not use our selection sort. Yeah, but that is very slow. Yeah. Here we try to use some good sorting algorithm, and here I just give you this, the general performance we have for a good sorting algorithm, n log n comparisons, close to this number, may not be exact, but very close, n log n. Yeah. Question? Yeah.
Do you know what the sorting algorithm we just talked about, its efficiency was?
Yeah, actually, there are several. Yeah, we can. One commonly used quicksort. Quicksort has this efficiency, but for average efficiency.
But what was the one we just did with the minimums? Do you know how efficient that one was? in
Minimum?
comparison? Yeah, the one we did, that we were talking about with the minimum values?
Oh, yeah, selection sort, right?
Yeah.
Yeah.
What was that?
That's 1/2 2n squared.
Oh.
Yeah, yeah, here we ignore some small number, yeah.
Yeah.
But here we can see the dominant term. The dominant term is that.
Yeah, that's,
Yeah,
that's big.
yeah. So, yeah, the difference.
Okay.
All right. All right, so the first step, we do the sorting and we pay. The cost is pretty big, but if it's smaller than, you know, method one, probably we like to pay this much. Okay, all right, so let's look at the next step. Yeah. Next step, how to check if any element is repeated in an ordered array. This time we have ordered array. Much better, right? Yeah. When we do the uniqueness check, now we can apply our comparisons on an ordered array. That's a big difference. That's a big difference, right? Yeah. Why is a big difference in increasing order? Think about it. If you have two elements in the array with the same value, what probability do you have?
They're gonna be right next to each other?
Yes. This time, you only need to do adjacent comparisons. You only need to do adjacent comparisons, all right? Because if there are two elements with the same value, you will find two adjacent elements with the same value. Because it's ordered. The whole array is ordered. Okay? Yeah. Adjacent comparison, we can treat it as local comparison, local, very local. In the first method, we need to do global comparison. Okay, that's very global. The first one with the last one, very global, right? So you, with this organized data, you do the sorting, you make the global comparison to local comparison. That's the big change. And how many comparisons do you need for this local comparison? Only compare two adjacent elements. Only two adjacent elements. Every time, two adjacent elements. How many comparisons do you need to do?
Wouldn't it still be n minus one? Well, oh, it's n minus one.
Yes, n minus one, not n minus one. Okay, two adjacent pairs, right?
That's
Two adjacent pairs. Yeah, n minus one. Yeah. Good. Yeah. You can write a code, very simple code. Yeah. You only check, compare two adjacent values. Okay. If they have the same value, return false. Return false. False means not unique, right? The whole array does not have unique values. Otherwise, if you auto check, you know, you couldn't find two adjacent values the same, return true. Return true unique. Whole array is unique. Okay. Yeah. Now we need to compare these two methods. So our last step, we need to compare these two methods. And this one we need n minus one comparisons.